Yes, good day, my fellow viewers. You are welcome to this episode. Basically, today we are also going to continue our test of mean difference. In our previous videos, we specifically looked at groups that are just two, and that's why we are concerned about computing for test of difference using the t-test, whether it is paired sample or whether it is independent sample. But the moment you have more than two groups, you are not eligible to use t-test to compute the difference. If you have three or more, you will have to use the analysis of variance approach. However, the analysis of variance approach can either be one way, two way, or multiple analysis of variance. As the name implies, we have one way Anova, two way Anova, or Manova, multiple analysis of variance. But in this class, we are focusing on one way Anova. In a class whereby we have 12 students, a 200 level class, and the performance in a particular course is categorized based on the mode of entry, UTME, direct entry, or transfer. You want to now establish, or you have stated an hypothesis that there is no significant difference in the performance. You have to use one way Anova. Why? Because there is nothing interacting in the group. So it's just one way. So you have three groups. This is the score of students that are coming in using UTME. We have 1, 2, 3, 4, 5. Direct entry we have 1, 2, 3, 4. And transfer we have 1, 2, 3. We also have a short course, or let's say an approach that is very straightforward. Only and only that we have to be careful. Our Anova summary table that we have here is telling us that we need to find the value of between group and within group differences. For our sum of square between group and for our sum of square within group, there is a formula that we have here. For our degree of freedom within group and for our degree of freedom between group, there is a formula also that we have here. For our mean sum of square between group, our mean sum of square within group, there are also formulas. And for our f value, because Anova is usually f value laden, meaning we have to compute the f value. So our f ratio is the ratio between mean sum of square between and mean sum of square within. What do we talk about a, b, c, d, e? There's no e anyway. A, b, c, d is the value that we need here. So we need a, b, c, d, n, and k. Our k is the number of groups. How many groups do we have here? 1, 2, 3. So obviously we have solved for k, which is 3. Our n is the total sample. Here we have our n, small n. I am using small n here. Our small n here is what? 1, 2, 3, 4, 5. Our small n here is 4. Our small n here is 3. But our capital letter N is N for group 1, N for group 2, N for group 3. And that will be 5 plus 4 plus 3. That will give us what? 12. So it implies that our capital N is the total number of samples available. So which is 12. We have been able to arrive at our N value. Our A, B, C, D is what remains. I purposely wrote this out to summarize what we are expected to do if we want to compute for A, B, C, D, and A, B, C, D rather. For us here, our D value is relying on the value of our A. So that means if we do not find A, we cannot find D. How do we now find A? If you look at what we have here, this table is saying group 1, and what is the number? Group 2, what is the number? So from what we have here, our group 1 n is what? 5. Our group 2 n is what? Our group 3 n is what? 3. I think we are filling the table already. Now this second one is saying summation x, and it is the for us to get our A, we need to find the sum of all the raw scores. But because it will be too cumbersome if we are writing it out one after the other, this table is telling us that we will find the sum of all the raw values in group 1, we will find the sum of all the raw value in group 2, find the sum of all the raw values in group 3, then we now sum the sum. When I say sum the sum, it implies that there is a grand sum, and that grand sum will give us our A. So without wasting much of our time, if we are to look at this now, our summation x, and summation x for each of the group, let us add 70 plus 68 plus 61 plus 81 plus 75 will give you what? 355. You can also confirm again. 70 plus 68 plus 61 plus 81 plus 75 will give you what? 355. While for the other one, 67 plus 65 plus 71 plus 74 will give you what? 277. While the third group, those that are coming in through transfer, 50 plus 58 plus 56, that will give you 164. And remember I said, if you are to write it in this box, you will just replace this by 355, this other one by what? 277, then this third one by what? 164. But your A value, our grand N is 12. We already know that, we already got that. Our A value will have the sum of all this sum, meaning 355 plus 277 plus 164. So let us do that. 355 plus 277 plus 164. That will give us 796. That is our A. 796. Remember I told you that for our D, for us to get our D, we need to get our A. Now that we are getting our D, quickly, before you forget, or before you make any mistake, quickly use that to get your D value straight, so that you know that you are left with B and C values alone. I am always using this to, at a point in time, before it's something that you just do so that you don't come back to it again. Once you get your A to be 796, quickly use that to get your D value once and for all. And how do you compute D? Our D is what? Is A squared over N. And this our N is the total, which is the grand N. What's our A value now? Our A value is 796. Remember it is A squared, so it will be 796 squared over, what's our N? Our N is what? 12. So 796 squared will give you what? 796 squared. It's not square root, it is square. 796 times 796. 633. 616. Divided by 12. Divided by 12. 52801.3. So that means our D is what? 52801.3. So this approach tells us that we have solved A, D, N, K. It remains B and C. So we will proceed. For us to get our B, if you look at what we have here, this denotation is telling us summation S squared. So it implies that we will come back to what we have here without really missing word. We will square them one after the other. Take note. We are going to square them one after the other. When I say take note, you have to be careful, one after the other. So it implies that if this is your x, then you have to have your x squared by the side. If this is your x squared by the side, If this is your s square by the side. Let us start. 70 square will give us what? That's 1 4
70 square.
4900.
4900. 68 square will give us what?
4624.
4624. 61 square will give us what?
3721.
3721. 81 square will give us what?
6561.
6561. 75 square will give us
5625.
5625. And you should recall that this thing is telling us summation x square. It implies that by the time you are able to establish the square of each of these raw values, then you sum it together for each group. So before we go to the other group, like I always say, you have to deal with one and finish it very well before you go to another one, so that you don't come back again. So let us sum this. 4900 plus 4624 plus 3721 plus 6561 plus 5625. That will give us what? 25431. So that means for UTME's group, which is group 1, we have 25431. So let us also go by, this is our summation x for group 1, summation s square rather. For the other group, 67 square will give us what?
4489.
4489. 65 square will give us 4225. 71 square will give us 5041. 74 square will give us 5476. Now when you sum all this, you have 4489 plus 4225 plus 5041 plus 5476. So that will give you summation of x for group 2, s square rather, and that will be a total of 19231. So it that implies that summation of x square for group 2 will be 19231. So we are left with the third group. 50 square will be what? 2500. 58 square will be what? 3364. 56 square will be what? 3136. So the sum of all these will give us summation s square for group 3, and that will be 2500 plus 3364 plus 3136. That will give us what? 9000. 9000. Perfect. So for the group 3 now, the solution of s square is 9000. That implies that we can now sum the sum. When I say we can now sum the sum, for us to get our b value, we will now do a grand sum. The sum of all the sum of the squares. If we are to take it naturally, comprehensively, it will be too cumbersome. We say summation of s square 1 plus summation of s square 2 plus, it will now be long, but summarily it will look very simple for us. So when we now sum the sum, that's the grand sum, we will get our b value. So let us do that. To get our b value, 25431 plus 19231 plus 9000. That will give us what?
53662.
53662. 53662. 6, 6, 2. So it implies that here now our B will be 5, 3, 6, 6, 2. We are left with C. In fact, for us, we are progressing. So our C should not be a problem. Ask me why. Just because summation x squared over n, we will get C value for group 1, which is the UTME, for group 2, which is the direct entry, and for group 3, which is the transfer. If you recall that ab initio, we have already computed our summation s. Are you getting the point? So if our summation s is 355, what we only need to do now is summation s squared. So we only need to take them one after the other and tell us summation x squared over n for each of the group. So for group 1, our summation s is what? 355. Let us square it over what's our n? That's how you have to be careful. Our n for group 1 is different from our n for group 2. So you will take each group one after the other, so that you will not, since the n is not the same. Are you getting the point? Unlike the grand n, which is 12, here we are looking at n individually. I hope that is clear. So here now we are going to have 355 squared over 5. The second one will be 277 squared over what? Over 4. The third one will be 164 squared over what? Over 3. Take note of that. Most times people go and use the grand n. Rather, it is not the grand n, it is the what? Individual group n. So let us do that. 355 squared divided by 5 will give us what? 355 squared first. 355 squared will give us
126025.
In exam situation, if you have the whole time, whether you are explicit enough, because at every stage you will be given mark. But if you don't have the whole time, you can jump some little steps, though you are also going to miss some little mark. But you have to be careful where you jump. So in the recess, if I am to rush here now, I will only use my calculator to compute this and write the final answer. But if there is still time, I will also state it out because it will, if I am going to get every mark, all those steps too are very vital. So let us 355 square will give us what?
12,625.
625 divided by 5, and that will give us 225.205. So it just implies that here now we are going to replace that 225.205. So we'll go for the next. So the next one says 277 square. 277 square will give us 729 divided by 4, and that will eventually give us 19182.25. So that implies that we are going to rewrite it here as 19182.25. Then the third one, 164 square will give us 268.96 divided by 3, and that will give us 268.96 divided by 3. 268.96 divided by 3. 8965.3. 8965.3. And for us to get our C, we will now do the grand sum of all the groups. Let us add We have 225.205 plus 19182.25 plus 8965.3. I hope this is correct. 12625 divided by 5.
126,025 divided by 5.
It's not 12625, it's 126,025.
Yes, divided by 5.
That is good.
5.
12, I'm coming. 126,025
divided by 5.
And that will give us
25205.
25205. Do you know when you are solving mathematical intuition, it will tell you that you are also wrong at some point. Meaning something will tell you that something is wrong somewhere. I was looking at the value, it's too small for this big value. And that suddenly tell me that go back and check. So at some point, that's why you have to be slow and steady sometimes. It is not speed that matters, it's accuracy that also matters. So let us now replace it with 25. So it's going to be 2525.205. So let us add 2525.205 plus 19182.25 plus 8965.3. That would be a very large value, and that will give us 5335 again 5335 what 2.58, and that will be the value of our C. So our C now will be 5352.58. If you look at what we have done so far, it's just that we have this question, we have this summary table, and we have this table that is also a summary of what we expect to find so that we can get here. So for us to get to this final version, which is our F ratio, we need to also compute all these computables. And this summary table here is the values that we need. Thank God we have attended to them. We have now gotten our A, our B, our C, our D, our N, and our K. We only need to go back to this final table where we are heading to. You know, we don't have to rush. Once you are already looking at the finish line, you also take care so that you will not go and fall and somebody will overtake you, so that you will get to your destination safely. Once you are able to get A, B, C, D, N, and K, you will now come here powerfully. So let us now go back to the summary table. More importantly, in our summary table, if I am to rewrite, I am not going to rewrite. I will only be cancelling once we are done. Between group, sum of square between group, we say C minus D. What is our C? Our C says 5352.58 minus what is our D? Our D says 52801.3. So this minus this will give us what? 53352.58 minus 52801.3. That will give us what?
Minus 551.
That cannot give me minus. 551. Now I am removing this just because we have solved it. So it's now been 5 what? 551.28. Yet to learn here. That one is gone. Hands down. K is what? 3. K means number of group. So how many group do we have? 3. So if our K is 3, K minus 1 will be 3 minus, and that will give us 2. That one is gone. That one is what? Gone. The next step, our sum of square between group, our degree of freedom between group. If you say that SS between group, sum of square between group, DF between group, degree of freedom between group. So 551.28 divided by 2 will give us what? 275.64. So we are done with this. Let us go to the next one. Within group now. For within group, we need B minus what? Minus C. Our B is what? 53662. Then our C is 53352.58. So when we say 53662 minus 53352.58, that will give us what? 309.42. B minus C. Now we go into this. Our n is what? 12. So if our n is 12 and our k is 3, n minus k will be 12 minus 3, and that is what? 9. You're not done. Next step, stepwise. So that's why if they give you enough time, you will take your time. If there's no time, you will rush, but at the last stage, because we are going to F value. That's our Anova. So if you are crash landing here, is worse. If you have not crash landed up to this point, I think it is better you take your time here and land safely. So the next one is sum of square within group, which is this, divided by degree of freedom within group, which is this. So let us do that. 309.42 divided by 9.
34.38.
344.
No, 34.38.
34.38. So that's our mean of square. This is what we call mean of square within group. Mean of square between group. Degree of freedom between group. Degree of freedom within group. Sum of square between group. Sum of square within group. Now somebody will say the next step is just to find our F ratio. But before we go there, let us just do this. What is our B? Our B minus D now. Our B is what? 53662. Then our D is what? 52801.3. I will just shock you now with something that will tell you whether you are right or you are wrong. Even without submitting, you already know. When this minus this will give you what?
860.7.
860.7. Good. What is our n? 12. 12 minus 1 will give you what? 12 minus 1 will give you what? 11. Now this year you will know whether you are right or wrong. The sum of these two must give you this. This plus this must give you this. The moment you are getting 10, something is wrong with this, or something is wrong with this, or one of them, but the moment this plus this gives you 11, it's telling you that you are almost correct. I am not saying you are 100% correct, but you are close to being correct. You are only correct at the final stage. So if you are saying you are correct now and go and relax, you might be wrong finally. Now, another thing is this. The sum of these two must give you this. Just try to add these two and see whether it will give you this. This plus this, it must give you this. Are you getting the point? So that's internal validation. Internally, you too shake your head and say, thank God. At least for me to get to this point, thank God. But if something is wrong, you will sweat profusely because you have gone through a lot of stage. So getting to this point, you will feel like, where will I start again? That's statistics, slow and steady. You need speed though, but accuracy matters. Now let us now go to the final. Why we are doing all this is our F value. For us to get our F value, mean of square between group divided by mean of square within group. So let us do that. 275.64 divided by 34.38, and that will give us 275.64 divided by 34.38.
8.017.
8.017. Our F value, which is the value of the Anova, is 8.017. More importantly, so our F value is 8.017. If you are to now test your hypothesis that you have initially stated, that there is no significant difference in the performance of the student based on their mode of entry, direct entry, UTME, and transfer. With this F value, your degree of freedom, that's another thing you have to take note. Anova usually have 2 degrees of freedoms. How many degrees of freedom did I say? 2. They have degree of freedom within, between, and degree of freedom within. So for you to test your hypothesis, it will now be F value giving 2, I am saying 2, what? 2,9. So I said F value 2,9. What is 2,9? 2 is between group degree of freedom. 9 is within group degree of freedom. 2,9. Then you now have your level of significance. If you are computing manually and you want to go and look for the table value, it then implies that your level of significance, which is 0.05, mostly in social sciences, you will now go and look for degree of freedom 2, where it corresponds to degree of freedom 9, under what? Under 0.05 to get your tabulated value. And from there, you will either accept or reject your hypothesis given the value you obtain in the tabulated value. Like I always sound this warning, you have to be careful of your decision rules so that you don't commit type 1 error or type 2 error as the case may be. So by implication, with this one way Anova summary table, if this summary table is only given to you, if this is missing, you can easily get it. It will be 11 minus 2, and that will give us 9. If this is missing, you can easily get it. It will be this plus this, and this will give you this. If this is missing, I repeat, if this is missing and this table is given to you, it will be this divided by this. If this is missing, it will be this times this. Get that right. If any one of them is missing, you only need multiplicative or divisive rule or additive rule to get the table fulfilled. While if this is missing, you only need this divided by this. So if this summary table is given to you, they have only helped you to solve it up to this point. They only need you to complete the table. I getting the point. But getting this table is what really matters. And you have to painstakingly follow all these steps that have been put in a way that is more simplified. So if you enjoy this video, you have to subscribe and watch other videos. So in our next incoming session, we'll also look at all other statistics and how it applies to research. Thank you for watching.